What are sharks' lateral lines, how do they work, and what are the physics behind them? Hi, I'm Tasha, and today we're going to talk about one of my favorite animals' super cool sensory systems. So, lateral lines are a sensory system in sharks and other fish that help them detect vibrations and water movement right about here on a shark. Lateral lines consist of a series of fluid-filled canals lined with specialized cells called neuromasts that help detect water pressure changes and vibrations. This allows sharks to feel the movements in the water around them. Hey, Olivia, do you think that you could tell us about these super cool concepts?
Hi, Natasha, of course. First, let's talk about pressure changes. Imagine you're by a pool, dunk a ball in the water, and it moves the water. The ball moves the water, which causes the pressure waves. Now think of a car driving over a bumpy road. Each bump is a disturbance in the car's movement. Similarly, when an object like a fish accelerates or decelerates, it creates pressure waves in the water, which the shark's lateral lines detect. It's all about speed and direction. Pressure and displacement go hand in hand. When something moves through the water, it displaces the water, which creates the pressure waves. Sharks sense these waves and can detect these movements, even from far away. These pressure waves are vibrations that travel through water, kind of like how sound travels through air. Sharks' lateral lines are lined with special receptors that pick up on these vibrations from long distances. It's like a tuning fork. Tap it and it sends out vibrations. Sharks can tune into specific frequencies of movement, allowing them to resonate with vibrations from things like fish. Hydrostatic pressure is the pressure that water exerts at any depth. Imagine you're in the ocean. The deeper you go, the more pressure you feel from the water around you. Sharks can sense these changes in pressure around them, helping them sense nearby objects or creatures. Also, remember diffusion? That's when molecules move from high to low concentration. When something moves through the water, it causes the molecules to shift around. Sharks sense these subtle changes, kind of like tiny ripples caused by a fish swimming nearby. Okay, Natasha, what's next?
Well, lateral lines work by detecting the pressure changes picked up by the pores as water flows over the shark's body. The pores then transmit the pressure changes through the canals, causing the fluid inside to move. This then bends the hair-like projections on the neuromass, triggering a nerve impulse to the brain. Some examples of sharks sensing things could be feeling the presence of prey or kelp around it by sensing the subtle pressure waves created by their movement.
Some of these subtle pressure waves you're talking about come from mechanical resonance. It's what happens when an object vibrates at its natural frequency. Imagine ringing a bell. When you tap it, the bell vibrates at a specific frequency. Sharks also use this trick. Some of these pressure waves could also be acceleration. This is when something either speeds up or slows down. When you hit the gas pedal in a car, acceleration creates disturbances in the environment. For sharks, this is like pressure waves in the water.
Nice! The lateral line system functions based off the physics of water flow and pressure differentials through the canals, triggering neuromass by displacing the fluid in them, signaling to the shark. How does water flow work?
Everything that moves through water creates a change in the flow. Imagine you're swimming through a pool. As you move, you push water out of the way, creating a current. When a fish swims, it creates a disturbance in the water flow. The shark's lateral line picks up on this disturbance, helping it detect movement from a distance.
Cool, so we've learned that the lateral line system works because it's a sensitive system of receptors that detects changes in pressure, vibration, and water flow, which enables the shark to detect movements, disturbances, and changes in acceleration around them. This is what makes it such a vital tool for navigating and hunting in sharks' aquatic environment.
Using all of these different concepts, we can understand how sharks can detect pressure changes in their environment and what factors play into these pressure changes.
So we learned that sharks' lateral lines are a series of fluid-filled canals lined with specialized cells called neuromasts.
They work by detecting the pressure changes picked up by the pores as water flows over the shark's body.
The pores then transmit the pressure changes through the canals, causing the fluid inside to move.
This then bends the hair-like projections on the neuromass, triggering a nerve impulse to the brain.
Sharks use their lateral lines to detect many tiny changes in pressure, vibrations, acceleration, displacement, and water flow.
All through the physics of pressure waves, diffusion, hydrostatic pressure, and mechanical resonance.
Now we're like vlogging at this point.
I'm filming, by the way. Go.
You're canceled.
Hopefully that'll work.
We can't use that in bloopers. Okay.
Causing them to do something.
You're done? Yeah, I'm done. Okay, great.